Learn like a pro.
Okay, let's put on our chemical detective hats for a minute. You've got a test tube, right? It's filled with some mysterious, unknown solution. And your job is to figure out what's hiding inside. Are we dealing with positive ions, negative ions, or maybe even some gases trying to sneak away? Well, let's grab our toolkit and crack this case together.
So here's our game plan. First, we're going to hunt down the positive ions, our cation suspects. After that, we'll shift gears to unmasking the negative ions, the anions. Then we'll have a look at any gases trying to make a run for it. And to wrap it all up, we'll get all our key suspects into a final lineup to go over the evidence one last time.
All right, first things first. We've got to identify those positive ions, or cations. And the key to making them show themselves, we're going to force them to form a solid, something we call a precipitate. Think of it as a trail of breadcrumbs, and we're going to follow it.
Now, every good detective has their favorite tools, and our first one is sodium hydroxide, or NaOH. We're going to start small, just a few drops into our mystery solution. Let's see what this first step tells us. Aha! Our first clues are in. And check out these colors. We get this awesome blue precipitate for copper, a really distinct green for iron 2, and that classic reddish-brown for iron 3. But hang on, look at this. Calcium, zinc, and aluminum all give us a white precipitate. That's 3 suspects giving us the exact same clue. So how are we supposed to tell them apart?
This is where the real detective work kicks in, right? We've got 3 leads, but on the surface, they all look identical. We need a second test, a way to dig a little deeper and figure out who's who in this lineup of white precipitates.
And here's the trick. We just add more sodium hydroxide, an excess of it, and watch what happens. If that white solid stays put, well, our culprit is calcium. But if it dissolves, if it disappears back into the solution, then we know our suspect is either aluminum or zinc. Just like that, we've narrowed it down from 3 suspects to 2.
Okay, but a good detective never relies on just one piece of evidence. So let's bring in our other trusted tool, aqueous ammonia. It works in a pretty similar way, but you know what? It can give us a whole different set of clues, which is perfect for confirming who's who. And this is where things get really interesting. With ammonia, calcium doesn't react at all. Nothing. And remember our 2 white precipitate suspects, zinc and aluminum? Well, when we add excess ammonia, only the zinc precipitate dissolves. The aluminum one stays solid. And the copper? It actually dissolves to form this absolutely beautiful dark blue solution. This test is the clincher for telling zinc and aluminum apart. All right, we're getting a pretty good handle on the positive ions, so let's move on to the next part of our investigation. It's time to unmask the anions, the negative ions. You'll see that each of these leaves behind a totally unique chemical fingerprint.
Here's your quick reference guide for the anions. Think of it as a fingerprint chart. For a carbonate ion, for example, you just add some acid. If you see fizzing and that gas turns lime water cloudy, boom, you found your culprit. Or for a nitrate, you gently warm it with NaOH and some aluminum. It'll release a gas that turns damp red litmus paper blue. See? Each one has its own specific test and its own telltale sign.
You know, sometimes our suspects aren't ions hanging out in a solution. Sometimes they're gases, and they're trying to make a quick escape from the reaction. But don't you worry, we've got tests to catch these escaping culprits right in the act.
And here's how we nab them. Hydrogen gives you that classic squeaky pop sound with a lit splint. Oxygen is kind of a show-off. It'll actually relight a splint that's just glowing. And good old carbon dioxide, well, it makes its presence known by turning lime water cloudy. As you can see, every gas has a signature move that makes it super easy to identify.
Okay, we've gathered all of our clues, we've interviewed all the witnesses, now it's time for the final lineup. Let's review the most critical pieces of evidence we have for telling our main coloration suspects apart. We'll focus on how they behave with our 2 key reagents.
So let's start the lineup with our first big test. What happens when we add excess sodium hydroxide? Just remember, this is one of the most important separation tests in our entire toolkit. Just look at how clear this is. When you push it and add more sodium hydroxide, only the precipitates from aluminum and zinc dissolve. That's it. The others, calcium, iron 2, iron 3, and copper, they all stay as solids. This is absolutely your go-to test if you need to separate aluminum and zinc from the rest of the pack.
And now for the final piece of the puzzle. How do our suspects react when we add excess aqueous ammonia? Because the patterns, they're about to change.
And here we go, a totally different pattern emerges. With extra ammonia, it's the zinc and the copper precipitates that dissolve. But notice this, aluminum, which dissolved in the NaOH, stays completely insoluble here. And that right there, that is the exact clue you need to tell zinc and aluminum apart. Case closed.
So there you have it. That's your chemical detective's guide to identifying ions and gases. You know the tools, you know the tests, and you know exactly what to look for. The only real question left is, with all these powerful clues now in your toolkit, what chemical mysteries are you going to go out and solve next?